The first video is Fundamentals of Electromagnetism and Electromotors. And the subtitles, Magnetism and Magnetic Field, the Basic Principles, Ampere, Faraday, Lenz and Lorentz, Inductance, Magnemotor Force, and Reluctance. The first picture, let's see it. This picture compares a permanent magnet and electromagnet. The permanent magnets generate a constant magnetic field while electromagnetic produced a field only when the current flows through a coil. Once the current stops, the field disappears. This makes electromagnet controllable and therefore widely used in electromotors. They allowed the magnetic field to be adjusted as needed, which is critical for torque control. The second picture is right-hand rules. The figure demonstrates the right-hand rule used to determine magnetic field direction. When the thumb points the current fingers is indicate the magnetic field direction. For coils, the fingers show the current direction and the thumb shows the field. This rule is essential for understanding how the rotor and stator fields interact the process motions. Let's see figures. This is Ampere's principle. According to Ampere's principle, a conductor carrying the current generates a magnetic field around it. The field strength depends on the current magnitude. The higher the current, the stronger the magnetic fields. In motors, rotor windings carrying current generate strong fields that interact with the stator field to produce torque. The fourth shows is Faraday induction principle. Faraday laws states that a change in magnetic flux induces an electromotor force, EMF, in a conductor. This is the basis for about motors and generators. Motors convert electrical energy into mechanical energy while the generators do the opposite. The fifth figure is Lorentz principle. Lorentz principle explains the torque generation in motors. Look at the C. And a conductor carrying the current in magnetic field experiences the force. The direction is given by Fleming's left-hand rules. And the tone for current, index for film, the middle finger for force. In motors, rotor windings produce current that, when placed in the stator field, experienced a force causing rotors. Yes, this figure is the classification the motors. General classification of electric motors, this figure summarizes the key motor classes used in vehicles: the brushed motor, the brushless BLDC motors, induction and synchronous motor, steps, and the servo motor. Each class differs in torque, speed, behavior, efficiency, maintenance, and current. The brushed DC is simple, low cost, but need brush maintenance. This is stator. The stator is stationary part that produces the magnetic field. It comprises the frame, laminated core, and the pole slots. Windings placed in insulated slots create the file interaction with the rotor to produce torque. Slot geometry, winding layout, and insulation quality directly affect losses, heat, and noises. The next figure is rotor. Rotor is the rotating part consisting of a laminated core, shaft, and the DC machines, armature windings connected to commutator segments. Current supplied where brushes interact with the stator field, generation lowers force and torque. Dynamic, the balancing and the tight tolerance minimize vibration and the acoustic noises. The next figure is commutator and brushes. The commutator mechanical reverse current in the rotor coils to sustain unidirectional torque. It is built from the copper segments rotating with the shaft. Carbon brushes, the preloaded by springs, contact the commutator to deliver current. Frame and the shields. The frame encloses and protects the motor, supports the stator core, and provides a thermal pad. Aluminum steel alloys are common, and shields the house the bearings and precisely center the rotor, the preversing the air gap. Automotive needs brake IP sealing, the corrosion resistance, and the high tension requirements. The last figure is bearings and seats. Bearings enable low friction rotation. The rotation. The groove, the ball bearings are typical. The proper lubrication, load rating, and alignment govern service life. Lack out lubrication cause wear and noises. Current installation removal promise damage is extent, life, tolerance in the bearing sets and shields control, rotor run out, and gap informality. Thanks to watch this video.